Okay, so yeah, guys, so welcome to the webinar. It's going to be maths functional skills, and I introduce myself. My name is Minas. Before we start, has anyone got any questions about the topics or anything that we're going to cover?
Is everyone all right? Yeah, no, we're fine, thank you.
Okay, good. I mean, if any do come along, if you want to make a note of them or write them in the chat box or anything like that, then I'll make sure that as we go through, we make time for that as well.
Okay, thank you.
So time-wise, I know it's down for 90 minutes. It may not go the distance. It may be about an hour or so. So if everyone's okay with that as well.
Yeah, that's fine.
Yeah. Okay. So we're going to be going through area, perimeter, fractions, and decimals. So I think an email was sent out earlier in the week as well about those topics. And if you've got any questions about either of those topics, like I said, either shout them out, or when I get to those sections, you know, we can have a little discussion about them there. Is anyone thinking at the moment already going, oh, you know, you're a little bit daunted by this, or you're thinking, oh, you know, I really don't want to be doing this? As we go through, I'll explain pretty much all the rules we need to know, and hence why, you know, double checking that we've got, you know, pens and paper. If you write these rules down as we go through, and again, watch it back later on, as long as you write them down and we understand them, it doesn't matter how the question is going to be worded or what the numbers are. We can just go back to the rule and just, you know, find the numbers from the question and put them into the rule. So as we go through, we'll see that. And I think we're going to kick it off with area here. Area, if no one's aware, it's calculating inside space. The levels that we'll be studying towards, I believe that everyone's at level 2. Is that correct?
Yeah, I think so.
Yeah, working towards level 2. Yeah. Okay. So with area, with the questions that you'll be coming up with, it will be questions about rectangles, not triangles, rectangles and squares. And questions may surround things like, you know, they'll give you a scenario. Someone wants to do a loft conversion, or, you know, they want to redesign a kitchen and there's so much floor space. It doesn't have to be floor space. It can be walls as well. You know, someone might be wanting to build a wall or wallpapering or tiling, and you may be asked how big the wall is and compared to how many tiles you might then need to buy, just giving an example. But if we're working with just squares and rectangles, as long as we know what the lengths are, all we do with squares and rectangles is just multiply the two sides together. So with it, so if we have a look at a square, with a square, all 4 sides are the same. So if you've only been given one side, then that's fine, because it's a square. They're not going to write, for example, 3 meters or 3 feet or whatever it is on all 4 sides. They'll just write it on one, and we'll have to identify that. Oh, okay, we've only got one side. Does it look like a square? If it is, then one side's enough. We'll just multiply that side by itself. But if it's a rectangle, which most of the questions are, then we have to identify what, you know, the length and the width is, and only then can we move forward in terms of working it out. Is everyone okay with that?
Mm-hmm.
Yeah, okay. Another thing to check is units. Now that word units, it's going to crop up, you know, as we go through this, and it might crop up as you guys, you know, do further work, etc. And all we're referring to is, what is the number? Is it money? Is it, you know, a unit of length? Is it weight? Is it something like that? And that's what we say the unit is. So if you've got a shape and one of the sides is in meters and the other side's in centimeters, you know, there's a little bit of a hurdle there. We can't just multiply the two together, excuse me, because the answer we get at the other end, we're going to be way off what it should be. Now, you might get a mark for your working out. So with an area question, possibly 2 to 3 marks, depending on what they're asking. Slight mistake might cost you a mark. But multiplying incorrect lengths, you'll get a mark for identifying that was length and that was width, but you'll lose marks in terms of your final answer. Here's a point to make that per meter, we have 100 centimeters. And, you know, you may want to try and find a conversion chart or something like that that breaks it all down. How many millimeters in a centimeter? Well, that's 10. So there's 10 millimeters that make up a centimeter. And then there's 100 centimeters in a meter, or you could say 1,000 millimeters in a meter as well. And depending on how long the side is would depend on what units we're working with. For example, if you're going to measure your commute to work, you're not going to give your answer in centimeters or millimeters, because that number would be in the millions, if you know, regardless if it's a short walk or a drive. So that's when we'll break it down and say, oh, it's so many miles or kilometers or meters, whatever. Same with money. And the same reason, you know, we don't just say, you know, oh, it's 115 pence. Although it's the right answer, we all know what everyone means. We have to use the correct unit. So in that example, 115 pence would just say it's £1.15. So we've got to make sure that we use the right unit as well. If any sides need converting, convert them, and then we're in a position to start moving forward. So I'll move on to the next screen. Okay, so we've got two examples here. The one on the left, got a rectangle, and then we've got a square on the right. So we've got top side, call it the length, 5 meters, and then the vertical side, 2 meters. Now, it doesn't matter if we confuse the length and the width, as long as we get the right numbers. 5 times 2 will give the same answer as 2 times 5. So with area, we've gone area equals 5 times 2. Another thing to mention, working out, I did say that before, although it might be easy to just go 5 times 2 in our head and just write down 10. Although it's the correct answer, you won't get the full marks. The examiners and the people that mark them, I want to see how you came to that answer. So 5 times 2, so that you've identified the two lengths, the length and the width, and then the answer in meters. Now, notice that floating 2 after the M, that represents meters squared. Now, it may be centimeters squared, millimeters squared, miles squared, but if we don't identify that floating 2 in terms of working with area, then there's marks to be dropped there as well. If you just write M, it's the incorrect answer in terms of trying to represent it as area. The 2 needs to go on there. It needs to be units squared. So times the 2 lengths together, work out what the units are, and then identify that it's area by making the answer squared. The one on the right is just 4, so that's 4 times 4, and that one you can see is a centimeter squared answer. And that only applies with questions with area, that's squared. Okay, is everyone okay with that if we move on?
Yeah, that's fine.
Brilliant. Any questions?
No.
No, we're good. Okay. So now, what we've just looked at before, they're your level 1 or entry level type maths area examples. When you start moving into level 1, level 2, it can get a little bit tricky. But as long as we remember the basics, which is we need to find a length and a width. Once we've got that, we're good to go. So if we have a look at this one. So sometimes we're asked to find the area of a compound shape. So like that one there, L shape, call it a kitchen, garden, whatever you want. Looking at it as it is, you might say, well, you know, I can't do this. There's no clear length or width. What do I do here? But if we look closer, there's a dotted line, a red dotted line across, well, one of the sides. And I've been able to split the shape into 2 rectangles. So if you have a look at the browner ones at the bottom, you can see that I've represented shape A and shape B. And if we look at them individually, they're just 2 rectangles, really. And then once we've identified that, we can then move forward and treat them as 2 separate shapes, calculate the area of shape A, remembering units and units squared, and then calculate the area of shape B, again, units squared, get your 2 separate answers, add them together, and that would be the total area for that shape there. The red dotted line that I've drawn, you don't necessarily have to cut the shape that way. You could have also drawn it vertically down. Now, it should let me, if I'm able to draw on the screen. Can everyone see that yellow line I've just drawn?
Yeah.
Yeah. So then what you could have done was you could have split it either along the yellow line or split it across the red dotted line. There's no major difference. The only difference is the length and the width for each shape will just be a little bit different. So if we do it, if we go back, we should be able to rub that out as well. Okay, so if we look at it as it is, if we were looking at shape A, you've got the 2 here down the right, and then the 10 along the bottom. And then you could do 2 times 10, that would give you the area of shape A. And then shape B, it would be the 4 along the top, and then the 7 down the inside. Now, careful not to mistake that by doing the 9 for shape B, because 9 doesn't relate to shape B or shape A, it's joint. So you've got to make sure that when you're trying to identify your lengths and your widths, you're covering the full length and the full width, and the number you've identified doesn't run into another shape as well. Sometimes it might be a case that, if it lets me, you might not even have that 4 or that 7. That can sometimes be deleted. But then what you can do is you can have a look at the shape and go, well, okay, fair enough, I've got 2 unknowns, but I can figure it out. And the way we can do that is, let's say the 4. We know it's a 4, but let's try and prove it's a 4 across the top there. We look directly down to the bottom. We know that the bottom, from left to right, is 10. Okay. We also know that if we go up a little bit more, we know that part of it is made up of this 6 here as well. So if we know that from left to right is 10, we've already got 6 of it. What is this missing dotted line that would make it 10, which would be the same as the opposite side? So then we just do the 10, take away 6, and that lets us know that it's 4. Again, let me rub out this 7. Well, we know it's there. So let's try and make sure that we know that that's a 7. If we have a look at here down the left, we know that this long yellow line now represents 9 centimeters. But if we have a look at the opposite end of the shape, we know that we've already got 2 here. We know the full side is 9. We know some of it is made up with 2. How much more do we need so that it makes the 9 that's on the opposite? Well, of course, it's 7. So sometimes, guys, remember, if there's missing sides or unknowns, you may have to, think a little bit more and work it out that way. Is everyone okay with that? Any questions? If so,
Yeah.
Okay, so what I'll do here is, we have a look at, say, this rectangle here. Oh, let's do that again. So we've got a rectangle here. That was 7, and that was 2. Okay, meters there, we're good. 7 times 2, and that would give us 14 meters. And remember, that's floating 2 squared. Okay. Now, another thing to remember is circles. Circles are treated slightly different. Now, this is definitely into level 2 territory. Okay, so with circles, we can't just calculate the area of a circle by doing length times width, because if we think about it, it's a circle, there is no length and width, but there's another rule we've got to remember. And has anyone heard of pi when it comes to math?
Yeah.
Anyone ever used it, or does anyone, you might be sat there thinking, you know what, this is getting a bit, too complicated, stay away from it. But pi is it's a symbol, it's a Greek symbol, and it's also a number as well. Generally, whenever we're working with pi, just think of the number 3.14. It does go on forever, but generally the number pi is stated as 3.14. And unless the question tells you to use a different number, it might say just use 3.1, or it might say use 3.14. It might give you a couple of extra decimals, but 9 times out of 10, the question will say in itself, use 3.14. So the area of a circle, that's what we'll call the area. And now we've got the formula here. Notice how there's no time symbol, division, add or subtract to separate that formula. When there's no separators like that, we automatically assume that we times them. So this formula now reads pi times r squared. Now there's that 2. Before that 2 was used in area. Here it kind of represents something a little bit different as well now. So what this is telling us is we can get rid of pi, and we can just write 3.14 times r squared. Now, what's r? Now, here's more letters getting involved. R, we know if we look at the circles to the right, it relates to the radius. So when you want to work out the area of a circle, you've got to look at the circle you've been given and try and identify a radius. Now, that is just from the center to the closer to the edge in a straight line. Sometimes the question might get a little bit trickier, and you might not be given the radius, but it might give you the diameter. So instead of them giving you from the middle to one of the edges, they've just gone all the way through the circle and they've given you that. And all we've got to do is we've just got to say, well, the diameter is just twice the radius. So if you've only been given the diameter, we've got to half it, and that gives us our radius. But if we've been given the radius, like the circle underneath, it's 5, off we go. And then we can just rewrite that as 3.14, which is pi, times 5 squared. Now, to square a number, 5 squared, that would be done by, it's the number multiplied by itself. So often it's kind of sometimes confused with, because it's a 2, I'll just do 5 times 2. Well, that answer actually gives 10. But 5 times itself, so 5 times 5, that actually gives 25. Notice the difference of 10, and that's going to put your answer off at the other end as well. So whenever you have to square a number, just know that it's whatever number you have to square multiplied by itself. Once you've got that, once you've got rid of pi and you've gone, well, pi is just 3.14, and once you've got rid of r squared by going, well, it's just 5 times 5, you're then presented with 3.14 times 25, because 25 is 5 squared, and then you've got an answer, as long as you get the units and that floating 2 correct as well, because although it's area and we've squared a number, we've also got to give our answer as squared as well. Moving on to the perimeter of a circle, it's called the circumference. So perimeter is normally associated with shapes, etc. But if we're talking about circles, that's called a circumference. Now again, we've got to use pi to calculate, the distance all the way around the edge of the circle. So circumference, oh, that's not drawn correctly at all. So the circumference we're associated with going around the edge. Okay, now that formula is 2 times pi times r, or you might say, well, 2 lots of r is just 2 lots of that, and then going through again, and you could just say, I'll just use the diameter. So either one of these 2 formulas is the correct one to use, but normally it's the one on the left, 2 times pi times r. Now you don't have to do anything with squaring numbers or anything like that, so you could just do 2 times 3.14 times 5, and that would give you the distance going around the edge. Now, another thing to mention here is when we're working with area, our answer is units squared, but when we're working with perimeter or circumference, we don't use that squared. We just leave our answer in the unit of length that the question was given. So if the shape was drawn and it said it's meters, and going around the edge, it would just be meters as it is, not meters squared. Okay, so we'll move on. Okay, and that brings us over to perimeter. So now perimeter, now that's the distance around the edge of a 2-dimensional shape. So a flat 2-dimensional shape going all the way around the edge, that is perimeter. And questions about perimeter, sometimes it might not say this, work out the perimeter of this fence. The question is going to be worded, for example, if you are working with, a garden, or if you're working indoors, if the question's trying to set out. If it is outdoors, it might say something along the lines of, you want to put a fence around all 4 edges of your garden. It might not even be all 4. It might say you just want fencing around 2 sides of your garden. So then you've just got to think, well, okay, I'm going around the edge, so this is a perimeter question, and I just need to be, concentrated on working around the edge of the shape that you've been given. The inside of the shape, remember, is area. The edges and the outside, that's your perimeter. So if we have a look at this rectangle we've got here to the right, we've got measurements, length of 4, width of 3. and then we've got another 4, which is the opposite side, another 3. So if we have a look at the working out, if you want to make it easier, sometimes what you can do is working with area, you know, do a little point in the corner because that's your starting point, and then work your way around the shape. So you've got a 4 there, a 3 there, another 4 along there, and then another 3 joining the shape back up, making it complete. Doing it that way, you'll make sure you're not going to go over the same edge twice, and also you've got to make sure that the 2 start and finish points have met. That way you can guarantee that you haven't missed out any shapes either. So again, uses, you know, the question may be set around farming, gardening projects, but real life scenarios, who uses perimeter? Well, there is farmers, you know, they're used in prisons, etc. Even at airports, that's always perimetered off. You may have heard terms, things like that. And that's all it relates to, is just going around the edge. Again, units, it's either meters, millimeters, centimeters, or kilometers. It's outlined here. And again, notice there's no floating 2. We don't need that, because at the end of the day, we're not looking at the inside space. It's just, it could 14 centimeters, just could be one long piece. And then all we can do is we can cut it down to shape, and then we've got 14. Whereas if it was one long piece, 14 centimeters, now we can't really fit that inside a rectangle. So perimeter and area, 2 different things there. If there's no questions, we'll move on. Yep.
Any questions? No, we're okay, thanks.
Brilliant. Okay, so again, we've got another perimeter one here. So again, going back to that area question where it was a complex shape like the L shape we've got here, and there might have been missing sides, so we've got to try and find those as well. So you've got to make sure that you've identified all edges and all sides, if there's any missing sides and things like that. And again, once you've done that, all we've got to do is make sure that are all the lengths and measurements in the correct units, and if so, have I identified any unknowns? Once you're certain of that, you know, you can find your starting point. So if I do it as the question's written out, actually, I believe the starting point is down here in the bottom left, and we just make sure we go all the way around the edge of the shape, making a note of all the measurements that we've been given. And make sure the shape joins, and then we write them all down as such, and then our answer afterwards. And again, notice that it's just 1 unit of length, 18 centimeters. And again, doing it that way, we're making sure that you know, we're going to get all the marks available for any sort of perimeter question. And again, if there's missing edges, so if the 6 and the 5 weren't there, we know that that top edge is 8. We know part of it is 2. So in order to make up the 8, if we've got 2, you know, we know that that's now a 6 as identified there. And if we have a look at the opposite side, we know this is 10 down the left. We know part of it is made up by the 5 on the opposite side. Again, I need 10. I've got 5. Then again, surely this has to be 5 again. So then we can then, you know, make that down there as it is down here, and you've got both sides the same. So again, with perimeter, to make sure that all unknown sides are identified, make sure your units are the same throughout. You know, make a starting point on the shape if you want, or a note in your head that that's where I started. Work your way around. Doesn't matter whether you go clockwise, anti-clockwise, as long as you hit all the edges. Double check, make sure that, you know, it's all correct. Double check with a calculator if you want, but yes, and that's all you have to do for perimeter. Okay, so now that brings us over to fractions. So we've got fractions to go through, and this, you know, it then throws us into decimals at the other end as well. So it should be maybe about another half hour or so, guys. So fractions, again, can be quite difficult if we're not sure what they are or how they're used. But normally, you know, we're working with the number 1. If you've got 1 of something, and as identified at the top in red, you've got the whole thing. You know, I've got one pizza, 1 cake, 1 whatever it is. As long as you've got all of it, you've got 1. Now, if whatever you've got is able to be broken down into sections, now we start working with fractions. So if you've got a cake or a pizza or whatever it is, let's stick with a pizza. You cut it straight down the middle. You did have one whole one. You've cut it straight down the middle. You've got two pieces, so you've got halves, whatever you want to call it. Okay, now imagine the pizza as a whole again. Instead of cutting it straight down the middle, we've cut it into 3 equal sections. Okay, those would be called thirds. So if something's split up into thirds, or if you've been asked to find a third of it, try and visualize or imagine whatever it is, cut into 3 equal portions, and I just want to know the value of one of those portions, and we'll go into that in a bit as well. Quarters, again, your whole shape split into 4s called quarters. Moving down, you could split the cake into 5 equal sections, fifths, moving down to 6, and so on, all the way down to 1/12. So you've got a 12th of something. Now, if you look at it, if you look at the I don't know, call it brickwork or whatever, you'll notice that some lines, you know, touch other bricks on the way down. So if we have a look, for example, at this half line here, we can't use any thirds, but if we have a look down here, the quarter line lines up with half, and that's made up of 2 quarters is equivalent to 1/2. If we move down again, the 6th line, that also hits the half line, and then we've got 3 either side. The 8th do it, the 10th and the 12th. So notice how you can kind of represent other fractions as a proportion of another fraction. So you might say a half, well, isn't that just 6/12? Well, then you could argue that, you could say, well, yeah, it is the same. If something's, you know, been split into 2, and you've got half of it, or whether you had 12 pieces and you've took 6, you wouldn't then go, oh, I've got 6/12 of something. We'll then associate that and say, oh, well, I've got half of it. And that's another thing with fractions. We've got to try and put the fraction in the simplest form. Now, I'm not sure if you guys have heard that term before. And an example of it is just what we've just done there. So if you had, for example, 2 quarters, yeah, again, you wouldn't say, oh, I've got 2 quarters. You would just say, well, 2 quarters is a half. So I'm just going to say half. Similar with money. If you have 2 50 pences and somebody says, oh, you know, how much have you got? You're not going to say, you know, 50 and 50. You'll say, oh, well, I've got, you know, 50p or half a pound and things like that. Okay, so we'll move on a bit. Uses, don't know if you see that. So we've got, you know, you've got in recipes, everyday uses of fractions. Where do we see them? You know, banana bread, it's got things like half a cup of this, 3/4 of a cup of that. If we have a look at here, at a quarter cup of oil or whatever it is, and all that means is you get a cup. Now, if we go back to the fractions wall, a quarter, that just means it's split into 4 equal sections, and I've just got to fill my cup to what is a quarter of that. Moving on, you know, if anyone that drives, you know, a tank of fuel, we'll always associate a full tank as 1. And then again, you know, you've got half a tank or a quarter tank and 3/4 of a tank or whatever. And then, you know, half a dozen eggs and things like that. But again, moving into what we pretty much do all day, every day, the time, you know, 1/4 past, 1/2 past, 1/4 to, we know that, you know, it's all fractions. An hour is broken down into 4, into quarters, and that's where we get that 1/4 past, 1/4 to, 1/2 past from, and things like that. Moving on, with fractions, percentages, and decimals, they're all linked. They can all be represented as each other. So again, you know, this, you know, it's handy that it's been recorded. You might want to refer back to this bit as well, or, you know, try and find this table somehow yourselves. But if we have a look at it, right at the top, if we're working with just numbers on their own, you've got 1. Now there's that whole, you've got 1. So if you've got 1, you've got all of it. Let's just associate that with, well, you've got 100% of it. Now remember, when you've got 1 whole 1, you can't go greater than the number 1 because you've only got 1, and that's how we identify it that way. So then what do we do next? Well, we can have a look at halves. So the fraction half, 1/2. If you've got half of something, it's true that you can also say, well, you've got 50% of it. Prime example of that is sales for clothing or cars or anything like that. A half price sale, you know that well, it's 50% off. Some stores like to advertise a half price sale, others will say 50% off. Same thing really. But in terms of the number one, half is 0.5. So if you've got half of one, you're at 0.5. Everyone okay with that so far?
Yeah, that's fine.
Yeah, okay. If we move further down this table, if we have a look at a fifth. So if something's broken down into fifths, we know we've got 5 equal portions. And again, if we're working in terms of the number 100, in terms of I've got all of it, how many times can, I split 100 into 5 equal portions? Once you've done that, then each portion is 20%. Because there's 5, 20% make up your 100. And if we're working in decimals, it's a 0.2. Now there's a pattern that's developing here in terms of turning a number from a percentage into a decimal, or even going from decimal to a percentage. We know that 33% over here turned out to be 0.33. We looked at 25%, 0.25, and as we go down the table, we can see that that pattern continues. The percentage can just be turned as 0 point and as it is. A tenth. So if something's being split into 10 equal portions, in terms of 100, it's 10% of it. 10 tens make up your 100. And in terms of a decimal, it's 0.1. So you're going to need 10 0.1s to make 100. The same reason you're going to need 10% to make 100. And you're going to need 10 1/10 of something to make it a whole as well. So that there, guys, you got fractions, percentages, and decimals there. Why have we got that? You might want to, some questions might say, work out a fifth of something. You might be thinking a fifth, well, that's just the same as 20% really. So rather than work out a fifth, I'll just, use 20% and treat the question that way. Nothing wrong with that. It might even make some steps a little bit easier. But again, on the other hand, if you see a fraction and you want to leave it as a fraction, you can do that. But if you start there thinking, oh, well, I kind of understand this fractions to percentages, maybe not at first time, maybe if you have a look at it again, you might get it then. But yeah, feel free, guys, if you want to change a fraction into a percentage or even a decimal and work with it that way. But generally, if you want to leave it in the form that it's in, then that's fine as well. Okay, so we'll move on. Okay, so now we're going to have a look at, well, okay, I've identified the fraction. I know how it looks. It's one number with a line and then another number underneath. But then, what do we mean? How do we then use that in terms of working something out? And again, as level 2, that's what we're going to need to do. And if we have a look at this screen here, so sometimes you're going to get asked to work out a fraction proportion amount of something else. And in this example I've used, you were being asked to work out 5/8 of 360. Okay. So the rule that we remember, so remember right at the start, said if you remember certain rules, then it doesn't matter what the question throws at you, as long as we remember the rule and look at the question and understand the numbers, and those numbers mean that part of the rule, then we should be all right, and we're not going to find much struggles with these types of questions. Okay, so we've been asked work out 5/8 of 360. So then let's have a look at this rule. So now this is the rule. So we've got to find the amount or the value that we're working on. So from the question that's been given to us, what is the number that the fraction needs to be applied to? There might be several numbers within the question. Some, 5, some 5, 6 mark level 2 questions can throw in numbers that you don't need for the working out, and they're just there to, well, predominantly just mainly throw you off. But so now if we know the rule, we can eliminate certain numbers from questions straight away, and you can identify, well, actually this fraction associates with this number. So there's the first thing we need to do. Now in the example that we're going through here, We've identified that 360 is the number we're working with, and the fraction 5/8 we've got as well. Okay, so find the amount or value that we need to find a fraction of using our example, 360. Then we need to identify the top and bottom numbers in the fraction, and I wrote them in brackets. Top number is 5, bottom number is 8. Top number, numerator, some, you know, the mathematical term. Bottom number, so you've got the numerator and the denominator, or top and bottom, more commonly known. So all we do now is divide our original value, so there's the 360, grab your 360 and divide it by the bottom number in the fraction. So that's 360 divided by 8. So that's the first step that we do. Then whatever answer that gives, we keep that answer. And then using that answer, we multiply it times by the top number of the fraction. Once you've done that, you'll then get what 5/8 of 360 is. And I've worked it out here. So first step, 360, I divided it by 8. Why did I divide it by 8? Well, that was the bottom number in the fraction. So that's this step here, and that gave me 45. I then used the 45 and times it by 5 there. And that gave me 225. Okay, so now I can say 5/8 of 360 is 225. Okay, so now that's how we treat a question like that. Now it doesn't matter if it said work out 2/7 of 1,800 and whatever the number is. We know what the fraction is, we know what the number is, we've got the rule, so it's just finding that original number, dividing it by the bottom, and then multiplying it by the top. So that's that. So we'll have a look at some examples. Okay, so we've got one here. So if you guys have got calculators there, if you want to, try this out, I'll give 30, 40 seconds if you want to have a quick go of this. Don't worry if you don't want. I'm going to give the answer as well, but it would be for good practice. So imagine a pair of trousers, jeans, wherever it is, and it's advertised as 4/7 off the original price of £129. Okay, now we very rarely see a sale like that, but hey, that's the question, we can work it out. So we know what the amount we're working with. It's a pair of jeans, originally priced at £129, and it's 4/7 off. Two things this question now presents. First of all, what is 4/7 of 129? That's the method we've just gone through. Secondly, what is the new price of the jeans? Now let's not get confused sometimes. Once you work out the 4/7, that's not what the price of the jeans are now. That's the discount you're entitled to. So then what you've got to do is go back to the price or whatever it is that the price is being affected and subtract the fractional amount away from it. We'll have a look in this example here. So if anyone's worked it out, well done. We'll go through an answer. Oh, where's it gone? Okay, so the first thing we need to do is you have to get 129. So if you put that in your calculator, it's 129. Divide that by 7, and it comes out as a fraction of 18.4285, etc. Now, with questions like that, the mark scheme will allow for, a degree of accuracy. Some of you might have stopped it at 18.4, some of you may have gone 18.42, and others even an extra third decimal as well. But a couple of things to remember is, first of all, we're dealing with money, and that's normally a 2-decimal answer, and you may need to do some rounding. So the 18.42, you may leave it as that. It'll also allow for, if you rounded it up to 18.43 as well. So now that's 129 divided by 7. I'm going to leave the whole answer in my calculator, and then I'm going to times that by 4. So we all might have a different answer, but we might be a fraction of a penny off. But again, mark scheme does allow for that. Okay, and I ended up with an answer of 73.714, and again, some more decimals. So that's 73.71, let's call it. That is 4/7 of 129. Now, 73.71, and if you take that away from the 129, you know, the pair of jeans that were originally £129 are now £55.29. Again, it's an odd amount for a price for something to come out as, but it just demonstrates that it doesn't matter what the fraction is or what the number is we're working out, it can be done. Now with that one, that's as tricky as it'll get. It was purposely done like that, so you'd get, you know, quite a lot of decimals at the other end. But sometimes the question can be kind to us. It might design the question that once we divide out, you know, we get some nice numbers where it's just 1 decimal, 2 decimals at most. It'd be brilliant if we always ended up with round numbers, but that's not always the case. There are decimals, and obviously after we've finished with fractions, that will go into decimals as well. Okay, so we've got a blank screen here. Let's assume we've got, I don't know, we've got a car, £12,352. Okay, so you've got a car advertised at £12,352, and let's say the fraction we're working with here is 3/5, so 3/5. So we've seen a car advertised at £12,352. The sale says that it's 3/5 off. You know, so let's have a look. Let's see what the discount is, and then once we've worked out the discount, we'll take that away from the original price of the car. You know, and then we know what the new cost of this vehicle will be. So we'll clear the screen. I'll just write that number down: 12,352, and it was a fraction of 3/5. Okay, so let's clear that. First thing to do is, you know, begin to identify the numbers. We've got the number, we've got the fraction. So 12,352, divide that by the bottom number in the fraction, which was 5, and that gave 2,470.4. So let's get that written down: 2,470.4. The next thing we need to do to that now is, remember, we've divided it by the bottom number. Now we need to times it by the top, and the top number was 3. And that gives us 7,411.2. So 7,411.2. So now all we've done here, all we've worked out is 3/5 off the original price, which was 12,352. Okay, so we've worked out that to be £7,411.20. Now we've got to subtract that from the 12,000. Okay, so that gives us 12,352. Take away 7,411.2. Okay, and that gives us £4,940.80. Now, was anyone working that out with us, or?
Yeah.
With £4,940.80. Now, what we've got to remember here is, as cruel as it might sound, in terms of, you know, we've gone through all that. It was a tricky question. We've worked it out. If we left it as what's shown in front, we're not getting the fuller marks. The question at the start laid out that it was, you know, it's to do with money. It's the price of a car. So our final answer would need to be identified as currency, or, you know, whatever currency money the questioner said. It could be dollars. You might be working exchange rates and questions and things like that. So you've got to make sure that you identify the correct units. And that goes with all types of questions. If the answer you've got turns out to be so many pence or miles or kilometers and things like that, then your answer needs to represent that as well. Okay, so that rule there with fractions: identify the number you're working with, identify the fraction, divide by the bottom, multiply by the top. And then obviously, guys, it depends on the question. If you're working with a sale item and things like that, once you've worked out the fractional amount, you've then got to subtract it from the original. And that can work the other way as well. The question might say, you know, the sale's finished now, and it was 12%, or, you know, a 2/5 sale, the sale's over, and the item is going back to full price, then the only thing that changes there is that little bit at the end. Instead of taking it away from the original, we're adding it to that amount, and that's, you know, identifying the price increase as opposed to a price decrease. But most questions will be, you know, a price decrease will be going down. So we'll move on to the last bit of today's session, and that's decimals. And it worked out well, it was purposely done that decimals followed fractions, because working with decimals there, we saw, working with fractions there, we did see a lot of decimals. So again, looking at decimals, it's clearly shown that they appear absolutely everywhere. And, you know, we will work with tenths. Now, that word there, tenths. So that's what we normally associate with decimals. It could be tenths, thousandths, hundredths, it could be anything. And all that means is, after the number, how many decimals have you got? If it's tenths, chances are there'll be 2 decimals, hundredths, 3, etc. If we have a look at that example, all it means, so we've got 0.9, and all that means is we just need 1 more tenth to make it a whole number. Okay, so we had 0.9. If we add to that 0.1, we've got our whole number. And that's basically, you know, the basics of decimals. So you've got, you know, where do we see them? You've got money, £158.43. So there's a decimal there. The time there, 9.58 seconds. 100-meter men's world record, that is, in fact. It's used in Formula One. It's used in, you know, athletics, track and field. It's used, you know, absolutely everywhere. You see fractions, the price of petrol at the petrol station before we decide whether we're going to use this one or not. It's a price, it's in decimals, and, you know, and we see them everywhere, from weight to even cars, 3.5 litre engine, etc., things like that. Now, with decimals, the quickest thing to do can be just to have a look at the decimal. Let's have a look at the numbers I've got. Let me pick up the calculator, and I'll just punch it in that way. I'll get an answer, I'll write that down, and then we'll move on. You know, you might get lucky, you know, that might work. However, you're not going to get all the marks that are available for that question, and that brings us back to working out. You know, the marks are collected for working out. Plus, if you're using a calculator, working with all these decimals, or can you guarantee your accuracy in the calculator? Did you put the decimal in the right place? Have you read the calculator correctly from the screen to the piece of paper? Mistakes can be made there. Write them all down, and, you know, it might be a case of the good old, you know, back to school method of, you know, line the numbers up vertically and add and subtract our decimals that way. Doing it that way, obviously, you know, you're going to build up your mental math capacity and things like that. And always at the end, if we're unsure as to whether we've done it right or wrong using the pen and paper method, then, you know, go to your calculator and just double check the answer that way. But we'll have a look at some examples. Another thing to remember is there's not so much rules as such in terms of, you know, identify this, and if a number's that, we do that. No, it is just a case of lining the numbers vertically. Now, it's not just the numbers, it's more the most important thing here is the decimal point. Now, when you've stacked all your numbers up, whether you're adding together a shopping list or lap times or whatever it is, you've got to make sure that your decimal point lines up vertically with all the numbers. So the dots for all the numbers are stacked up on top of each other. Like in the example here, you can see the red decimal, 14.25 and 16.01. Notice the 2 red decimals vertically aligned. Okay, if we look at the numbers to the right, 55.69 and 15.32, the decimal doesn't align correctly. You know, it's 1 space off to the right. If you left it like that and you try to subtract, yeah, you'll get numbers at the other end, but it won't be the correct one. And unfortunately, with that one, there's not really much in terms of giving you marks for working out, because it all started with that one initial mistake of not having your decimals lined up. Once you've done that, and it's that, you know, the borrow from the left rule when in terms of, you know, good old takeaways, sums. So we'll have a look at one. Okay, cool. So that, like we said, so occasionally we're presented with problems, and we've got one like this. Even if you stack the numbers on top of each other so that you've got the highest one, the largest number, and then the smallest number underneath, you can still be presented with a little bit of a situation as to what we've got here. So what we had was 5.25, take away 2.16. Now, straight away, we know that the decimals are aligned vertically. Let's start all the way to the right, and we've hit a hurdle straight away. 5, take away 6. You know, guys, can't be done. And then borrow from the left. And that's what this next picture will show. Apologies, you know, if everyone's comfortable with this method, but you know, I thought we'll go through it. It's the one thing that, you know, can, you know, get us the most amount of marks when it comes to working with decimals and things like that. So we couldn't do 5 take away 6, so we borrowed from the 2. So we borrowed from the left, and the 2, so that's made the 2 a 1. But more importantly, it's made our 5 into 15. Okay, so then we can do 15 take away 6. Yep, that's doable. The next line would be 1 take away 1. Yep, that's doable as well. And then on the opposite side of the decimal, can we do 5 take away 2? Well, yeah, so we have to borrow from the left there on one occasion. And if we have a look at the answer here, that's how that would be worked out. Okay, so 15 take away 6 was 9, 1 take away 1, 0, and 5 take away 2 there is 3. So 5.25 minus 2.16 gave us that 3.09. Anyone got any questions on that at the moment?
No.
No? Okay. Okay, so another couple of minutes, I'll do a couple more examples. Open it up to any questions, guys, if you've got any questions or if you want me to go through anything again. And that'll be us. So another, what, I'd say 5-10 minutes maybe. Okay, so going back to that borrowing from the left rule. So if we have a look, let's try this 1 point. Can everyone see that okay?
Yeah, that's fine. Yeah.
Yeah. There. Do you want to have guys want to have a go at that one? So we've got 1.89, take away 0.98. And again, you know, I've put the big number first, the small number underneath. My decimals have aligned. Make that one a little bit bigger. It's clearly seen. So yeah, straight away, 9 take away 8, etc. we can do. So I'll give maybe another couple of seconds on that. Or as we go through, we can mark it that way as well. So straight away, we can start with 9 take away 8. Yep, we'll have that, 1. Okay, next problem. Next column, you could say 8 take away 9, unfortunately not, but borrowing from the left. So we're going to cross out this 1, make that a 0. And now 1 then makes the 8, 18. Yep, now we're okay. 18 take away 9, that leaves us with 9. And then obviously the 2, 0, 0 take away 0, 0, put the decimal in the right place. So 1.89 take away 0.98 gave us 0.91. Okay, we'll clear that. 527 point, I don't know, 14, let's say. Yeah. And 181, just to make it a bit difficult, 36. So again, purposely done that just to make us get into the habit of that. But so we've got there 527.14, 181.36, and again, we're borrowing from the left, and purposely done it this way. We might have to borrow more than once on this occasion. Again, I'll go through that. 4 take away 6, straight away, can't be done. Okay, so the 1's become a 0, and the 4's become 14. We can do that. Yep, 14 take away 6. That gives us 8. Again, we've got 0 now. You know, 0 take away 3 can't be done. But we can, you know, jump over the other end of the decimal. We borrow from the 7. The 7 becomes a 6, and the 0 becomes a 10. Okay, and now 10 take away 3, we can do that. 7, the decimal needs to align, so that's where we'll put that decimal. Again, moving over, 6 take away 1, yep, doable, that's 5. 2 take away 8. Fortunately not. borrow from this 5 to the left. 5 becomes 4, and the 2 becomes a 12. 12 take away 8, 4, 4 take away 1, 3. 345, 78. Now again, well done anyone that got that as well. One last one, and then we'll have some questions if there is any. Nicely, 28.37, 12 point, what can we have? Let's have 8, 5. And again, subtract those. Can everyone see that?
Yeah.
Yeah. Okay. So with that one, last one we'll do. So 7 take away 5. Yeah, that's doable. 2. And again, now here we go. Borrowing from the left. 3 take away 8. Can't do. Let's drop that. 8. Turn it to a 7. 3 becomes a 13. 13 take away 8. Yep. 5. We can have that. And then that's 7 take away 2. 5. 2 take away 1. 15.52. So that was that with decimals. There is sometimes a little bit more to it. There might be more in terms of, and that with decimals, it's not just doing it like this. You know, we can move into rounding to 1, 2 decimal places and things like that. And guys, there might be an opportunity to attend, you know, another session like this in the future where we can cover other topics. But if we just move on, is there any questions from anybody? You know, is there anything else that you want me to go through?
No, I think everyone's fine, thank you.
Brilliant. Guys, thanks for listening. And what we'll do is we'll send out some links and we'll make the video available should you guys want to, you know, come back and review it. But yeah, thank you very much, guys. Have a good day.
Okay, thank you.
Take care. Bye.